Section 4.5, Exponential and Logarithmic Functions, Part 6. To solve an exponential, we isolate the logarithm on one side of the equation. Remember, sometimes we might first use the laws to get them into a single logarithm. Remember, Law 1 said log base A of AB. If we're multiplying, we can separate with addition. If we're dividing, we separate with subtraction. If we have a log base A of A raised to a power, remember the power can be written out front. Okay, so in solving our equations here, we're going to write as one single logarithm, so we're going in this direction. We're going to take our expanded logarithm and write it into a single logarithm. So let's start that here. They are of the same base. What's the base? Base 10. These are both base 10. Since they're both base 10, we can write them in a single logarithm. Now this is addition, so we're going to combine x and x minus 3 with multiplication. Now that I have an isolated log term, there's only one log on both sides of the equation, then I can exponentiate. And that's this part here. We're going to exponentiate. Since this is log base 10, we're going to make it the exponent of 10. What I do on the left, I must do on the right. So we exponentiated base 10. These will cancel out, leaving us with x squared minus 3x equals 10, or x squared minus 3x minus 10 equals 0. How do we solve a quadratic? We're going to solve a quadratic by either factoring or the quadratic formula if it doesn't factor. This one happens to factor. We end up with x equals 5, and we end up with x equals negative 2. Now, when we solve for our variable, we want to make sure to check our answers with the logarithms. When we think of a logarithm, the domain of a logarithm is from 0 to infinity. I can't plug in 0 into a logarithm, and we cannot plug negatives into a logarithm. So that means for our solution, we can't have that negative 2. That's called an extraneous solution. The only solution that we can have is x equals 5. Problem number 70. Use a graphing device to find all solutions of the equation rounded to 2 decimal places. Some problems can't be done by hand. Sometimes we have to do a problem using our graphing calculator. Here's one where we're using our graphical device to find solutions to the equation. Okay, so we're going to grab our calculator. We're going to go to y equals. Now this is a TI-86. They're trying to repair my TI-84. Hopefully that'll be soon, but for now I'm just kind of having to use this TI-86 model. But we get the idea because thankfully we were able to practice before we went virtual. Okay, in y1 we're going to plug in the log of x. Into y2 we're going to plug in x squared minus 2, and that's what I did already in the calculator. Okay, I'm going to go with a zoom standard. So we're going to do a second. We're going to do a zoom and standard. That's our negative 10 to 10. There's our log graph. and there's our x squared minus 2 graph. Now here's where you don't want to always depend on the calculator to do all the work for you. You want to think logically of how your answers are going to look. When we did log graphs, did log graphs just all of a sudden stop? No, log graphs approach the y-axis since the y-axis was the horizontal asymptote. So this has two solutions. One solution here, but another one because the log graph has to approach the y-axis. If we zoom in a little bit, I'm going to say zoom in. We're going to see our log graph first. And notice it doesn't just stop there, it comes all the way down. And then we have our x squared minus 2 graph. So I'm going to grab this picture and put it in our notes. So when you practice graphing, you'll make sure to get the same picture that we did. Okay, so there's our picture. We just have to know that when we studied the graphs of logarithms, that this didn't stop all of a sudden here. It came down and approached the y-asymptote. So it actually looks like this. And then when we throw in our x squared minus 2, we're going to see that we have two solutions, not just one solution. If we go back to our calculator, we're going to look for the intersect feature. Now again, my calculator is a little bit different, but if I go to the intersect feature here, remember your screen should look like this. Okay, so if I'm on the first curve, looks like we're almost here. Maybe we'll go a little bit more to the right. Okay, so that's as close as I can get on my first curve. So I'm going to hit enter. I'm trying to get to that point of intersection. We're going to go to the second curve, and I'm just going to go ahead and leave it there. I'm going to hit enter, and then the calculator says, do you have a guess at the answer? I never guess, I just hit enter. So try to get as close to the intersection point as you can, and then just hit enter 3 times. First curve, enter. Second curve, enter. Guess, enter. If there is an intersection, then the word intersection appears and the XY coordinate for that intersection, just like we see here. So I'm going to take a picture of that and put it in our notes so we know where we got our answer from. Okay, so our first point of intersection is going to be right here. So that's the point 0, 1, 0, 0, and then -2 if we were to round to 2 decimal places. Okay, what's our solution? Let's look back at problem number 70. What's our solution? We want an x value that when I plug it on the left side, it's going to equal what's on the right side. We want an x value. So this solution tells us x equals 0.01 to 2 decimal places. Okay, so we're going to do the same thing for the other intersection point. We're going to get to the intersect feature. We're going to move our cursor to the intersection point that we're looking for. All you have to do is just get as close as you can and then just keep hitting enter. You hit enter 3 times. Once you hit enter 3 times, if there is an intersection, you'll see the word appear on your screen. There it is, intersection, and then the point at which the intersection occurs. Okay, I'll grab this one real quick. Okay, for our second solution, which is here, you see the point 1.47. 0.168. Now, which one is the solution? When we come back to problem 70, we are looking for an x value. So the x at which these two intersect is 1.47. And those are our two solutions. We wouldn't guess at this second solution unless we remembered what our log graph looks like. So don't just go by your calculator. You also have to know some things about math.